All right, everybody, thanks for coming. This is going to be our final video in our exponents unit, and we're talking about how to apply operations to numbers in scientific notation. And what I think you're going to see is that multiplication and division are pretty simple, and that's why I start with them. And addition and subtraction are a lot more complicated. So let's start with multiplying and dividing. Multiplying. Just like any other numbers with exponents, you're going to multiply your bases and you're going to add your exponents. The only major difference here is that you're going to make sure to keep times 10 in your answer. All right, so if you have the two scientific notations, such as the ones you see here, so if you have 1.2 times 10 to the 9th times 3.65 times 10 to the 8th, we're going to multiply the bases 1.2 and 3.65. As you can see here, we're going to multiply those bases, and then we are going to add the exponents. So the exponents here are 9 and 8. All right, so when we multiply this, we get 4.38, and then we add here, we get 17. What may end up happening, occasionally, is that your decimal point might shift. You just have to make sure that if that happens, that you adjust for it in your final answer. So I don't know, we may see that happening. So let's do a couple practice. All right, so this problem, we got 3.6 times 10 to the 4th times 5.8 times 10 to the 5th. So if I just write out the work I'm going to do, I'm going to end up doing 3.6 times 5.8. All right, I'm going to just put that in parentheses so I know I'm keeping that separate. And then we're going to multiply that by 10 to the 4 plus 5, so which is, of course, 9. So let's multiply 3.6 times 5.8. All right, so this is an example of what I was talking about. So we get 20.88. All right, and when we add 4 plus 5, we get 9. So this is not yet truly in scientific notation. We are going to have to bounce that decimal point one space over so that our base number, I'm going to write in a different color, our base number ends up being 2.088. So by doing that, that's actually going to change our exponent, because now it's going to take a higher power of 10 to actually equal the real number that this is standing for. So that means that we have to increase our exponent by 1 since we had to move our decimal 1 space. All right, so this will end up being 2.088 times 10 to the 10th. All right. Hope that made sense. All right, so let's try this one. 7.84 times 10 to the 3rd times 5.21 times 10 to the 8th. So we start with 7.84 times 5.21. All right, and that's going to be multiplied by 10 to the 3 plus 8 power. All right, let's do our multiplication here. 7.84 times 5.21 is going to give us 40.8464 times 10 to the 11th. All right, once again, this is not yet in scientific notation. So we have to move our decimal 1 space to the left. By doing so, that means we have to increase our exponent by 1. So we're going to end up with 4.08464 times 10 to the 12th. And that's not that. All right, there we go. Okay, so that's multiplying. Not too bad. Division is going to be kind of similar. So just like with other numbers with exponents, we divide the bases and subtract the exponents. Only difference here is that we keep times 10 in our answer. So for example, if you have 6.2 times 10 to the 7th divided by 3.1 times 10 to the 4th, you divide 6.2 by 3.1, and then you subtract 7 minus 3, and we get 2 times 10 to the 4th. Let's do a couple practice problems. So here we have 9.8 times 10 to the 10th divided by 3.2 times 10 to the 4th. So we would start with 9.8 divided by 3.2, and that's going to be multiplied by 10 to the 10th minus the 4th. So let's do our division. 9.8 divided by 3.2, and we get 3.0625. And if we do our subtraction, we get 10 to the 6th. So 3.0625 times 10 to the 6th. Okay, we have here 1.52 times 10 to the 7th divided by 7.8 times 10 to the 3rd. So we would be dividing our bases. So 1.52 divided by 7.8 times 10 to the 7 minus 3. Okay, so when we go ahead and that should be divide, not multiply. When we go ahead and do our division, 1.52 divided by 7.8 gives us a very long number. Let's go ahead and round it just for the sake of time. So let's say it's 0.195 times 10 to the 4th. Okay, now this is not in scientific notation because we need this decimal point to be right in front of this 1. So I would rewrite it as 1.95. All right, now because I did that, I am not going to need my exponent to be as high. I'm going to need a lower exponent. I'm going to need 10 to be raised to a lower power in order to get the true answer to this, or the true number that this represents. So we would decrease it by 1. We would have 1.95 times 10 to the 3rd is what this actually would be as scientific notation. Okay. All right, adding and subtracting. Adding and subtracting is a lot more complicated. Now, if the tens have the same exponent, it's simple. You just add the coefficients.
Please select Senti of your visibility. Please dial extension 4308. This is the Senti 4308. Thank you.
So, with this problem, we would just be adding 1.3 and 1.5 to get 2.8. And we would have the same base. It would still be multiplied by 10 squared. Okay, so that's very simple. It gets tricky when they don't have the same exponent. So here's how you do that. First, factor out the difference of the larger exponent. So with this problem, we have 7.2 times 10 to the 12 plus 8.4 times 10 to the 9th. 12 is the larger exponent. So we're going to factor out the difference between 12 and 9, which would be 3. So 7.2 times 10 to the 12th, we're going to write as 7.2 times 10 to the 3rd times 10 to the 9th. And that's going to be added to this. Now, we simplify what we just factored out, meaning we find what it equals. So 10 to the 3rd would be 1,000. So this now becomes 7.2 times 1,000 times 10 to the 9th plus 8.4 times 10 to the 9th. Then we would multiply our coefficient by the number we just got. So that would give us 7,200 times 10 to the 9th plus 8.4 times 10 to the 9th. All right, then we can add the coefficients. So 7,200 plus 8.4 would give us 7,208.4 times 10 to the 9th. This is not yet in scientific notation, so we would have to move our decimal point to the left 3 spaces. That means we have to change our exponent. We have to increase it by 3. So this would be 7.2084 times 10 to the 12th power. Okay? Seems complicated. Let's see. How we would do a couple of these. So let's just do one. Let's do the subtraction. So 8.7 times 10 to the 14th minus 5.12 times 10 to the 10th. So factor out the difference here. So this would be 8.7 times 10 to the 4th times 10 to the 10th. Minus 5.12 times 10 to the 10th. All right, simplified 10 to the 4th, so this would be 8.7 times 10,000 times 10 to the 10th minus 5.12 times 10 to the 10th multiply this and we get 87,000 times 10 to the 10th minus 5.12 times 10 to the 10th. Go ahead and subtract. So I'm just going to go and do this here for the sake of time. So we get 86,994, so 86,994 and 88 hundredths times 10 to the 10th. We have to move our decimal point 1, 2, 3, 4 spaces, so we have 86,994, 88, decimal point after the first 8, times 10 to the 14th. Okay, that was a lot to take in, but I hope you learned from it.